Hello, good evening, participants. Good evening, everyone. Welcome you all on our Atal Online 6-day Faculty Development Program on emerging frontiers in AI and machine learning for next generation engineering applications. Today is our day 3 of our FDP program, and it's time for our fifth session of our FDP. But we are waiting for our expert to join, and sir is going to join within few minutes. So please be patient and be joined. Let's wait for a few minutes for him. Then we will start our session. Thank you. Okay, welcome. Good evening, sir. So, once again, welcome everyone. Welcome to the third day of our 6J FDP program. And now it's time to proceed for our fifth session of today. Means the first session and in total the fifth session of our FDP. And for which it's my honor to introduce our distinguished expert speaker for today's session, Dr. Pankaj Kumar sir, who is Professor and Associate Dean, Computer Science and Engineering at the National Institute of Technology, NIT Rourkela. Sir has a career spanning of 27 years of teaching and rich research experience. He is highly respected academician and researcher whose areas of interest include computer vision, image processing, computer graphics, bioinformatics, biometrics, video surveillance, and the machine learning. Throughout his career, Sir has made remarkable contributions to the field of artificial intelligence and has guided numerous students and researchers in developing the intelligent data driven systems for real world applications. Today, Sir Pankaj Kumar will be delivering his talk on the topic computer vision using AI, and his session will provide us with valuable insights how the artificial intelligence empowers the machines to analyze and interpret the visual data, leading to advancements in the automation, robotics, and intelligent imaging systems. On behalf of organizing committee and our SSTC, I warmly welcome you, sir, and look forward for an engaging and enlightening session. Once again, welcome Dr. Pankaj Kumar, sir.
Thank you.
Um, yes, sir, with your due permission, can we start the session?
Yeah.
Yeah,
Am
yes.
I audible?
Yes, sir, you're audible, sir. You're audible.
Yeah, let us start the session. Yeah, let me share my slide.
Yes, sir. Yes, sir.
Hope it is visible now.
Yeah, yeah, yes, sir. It's visible.
Okay. Yeah. Uh, uh, Good evening, one and all. It's a huge gathering, I suppose. By the way, how much time do I have?
So our schedule is from 6 p.m. to 7:30 p.m., sir. 1.5 hour
That
session it
is
is, which also includes the discussion part. And
okay.
then,
Okay.
yeah, yes, sir.
Thank you. So, may I know a quick feedback from you, madam? What is uh, the the population, the audience population comprising what kind of background do they have?
So mostly are the faculties from various institutes all over India, and
Right.
participants are from the different streams.
Okay.
This is organized jointly by the Mechanical and Electronics and Telecommunication Engineering Department. Some faculties
Right.
are from the computer science and from the electronics other branch also, sir.
Okay. Okay. Good. Good. Okay. Let us start.
Yes.
So the topic here is that has been given to me is computer vision and artificial intelligence, machine learning, etc. So it's indeed a very big area. So one of the smaller area of the sub area of the entire topic is low light image processing. This is I will be presenting couple of the works that me and my student we did together. This is his PhD work actually. So I hope you will find it engaging. So just to brief you what exactly this entire topic is. So if at all you are acquainted with image processing, one of the very basic image processing task is image enhancement. Another task is image restoration. Image enhancement is one of the very basic tasks. So, image enhancement has been doing good. I mean, decent work was there, quite established algorithms are there. But then it has, it is the algorithms, whatever are there, they are actually not they're actually inadequate in addressing one particular aspect. That particular aspect is the night vision, the extreme low light situation. Low light, forget about extreme, even low light situation also, it becomes very difficult in addressing the images and with the enhancement algorithms. So I'll be presenting first. Let me show you a couple of images. I hope you can see this particular image. And this is another image of low light. Now, this is actually low light image, but it has been artificially induced low light. So, or in other words, the brightness has been decreased. This is another such picture. This is another such picture. These are the corresponding ambient light pictures that have been taken. Left hand side is the low one, and the right hand side is the ambient light picture. Yeah. Some of the cases what you observed here. Now, these are a couple of more low light images, which are actually truly low light images. These three images have not been artificially made low light, or the brightness have not been decreased. They have been captured like that only, truly low light images. So if we analyze the intensity distribution of these three images, on the x-axis you can see we have pixel values ranging from 0 to 255. The scale is up to 300 here. The values are up to 255. And on the vertical side, the number of pixels that are there. As you can see, the number of pixels concentrates around the origin. So that means the pixel values are very low. It is most of the pixels are very low. If I can zoom it for you, it this is how it looks. Yeah, this is how it looks. And the second picture is also no different. The third picture is also no different. As you can see, the most of the pixels concentrate on the around the origin it concentrates. So the target here is to bring all these pixels evenly distributed along the x-axis. So that would actually generate a proper ambient light picture, and whatever things that are hidden here could be visible. So that is what the whole idea here is. Now, talking about a vision system, the human eyes are having a very complex vision system. With the human can see even in the night, daytime, with extra light, with extra low light. Yeah, we have been gifted in that way. Whether humans or animals, we are all gifted in that way. But the machines are not designed in that way. Now let us talk about a little bit on the different illuminance level when we are talking about extreme low light. So what actually low light means, and what actually extreme low light means. So let us talk about these two aspects first. So the nighttime illuminance level, it doesn't meet certain standard, and when it doesn't meet certain standard, we say the light level is very low. Yeah, but then what is the what is that standard? And when it doesn't meet a particular standard, what actually happens. So it's not just the low brightness. Low light image doesn't come with low brightness alone. It also comes with low contrast. The gray range is very narrow, as you have seen in the previous pictures. There is a distortion in the color, and in addition to all of this, there are abundant amount of noise. So when we capture an image under low light conditions, we are bound to get all these things in free, for free. Okay. So we need to deal with not just low light, but with all this. So how do we measure light? We measure candela. We measure using candela, lumen, or foot candle. These are different metric which is being used to measure light. Now let us talk about what are the commercial lightings, foot candles that are actually required on a typical office. It is something around 50 to 75. In schools, it is 30 to 100. In hospitals, auditoriums, there are different levels that have already been laid down by the people earlier. Particularly talking about architecture, residential areas, the bathrooms are bathroom, kitchen. These are the areas which are actually the light amount is very high compared to living room, bedroom, and all those. This is a typical picture that I don't remember the source from where I have taken, but typical scenario where in a what are the different lux levels that are required. Now, the standard requirement that I was telling, dark. When will you call something is dark? The lux level lies between zero point zero 0.01 and zero point 0.1. So that we call it as dark. Below the dark, there we have moonlight level, and below the moonlight, we have starlight level. So anything ranging from zero point zero 0.01 lux to zero point 0.001 lux, we call it as a moonlight level, and anything below zero point 0.001 lux, we call it as a starlight level. Okay. Having said all this, let us talk about what exactly brightness is. Brightness of an image. This particular term you must have come across while adjusting your televisions, adjusting your mobile phones. But what exactly the meaning is? The meaning is it is the overall lightness or the darkness that is available in the image. Similarly, what's a contrast is? The difference between the difference in brightness between the objects. You talk about two different objects or two different regions in an image. So the difference in the brightness is what is known as the contrast. Let us see a couple of examples here. I hope you can see the image where the brightness is too high. When we say brightness is too high, we say the the pixels have been saturated with the extreme high light conditions. Brightness is too low. The dark pixels have been saturated. Here the contrast is too high. The black becomes too black and the white has have become too white. Similarly, the contrast is too low. The objects and the backgrounds, they fade into each other. You do not recognize which one is object, which one is foreground, which one is background. In such a situation, you say the contrast is too low. Let me repeat the images once again. Brightness is too high, brightness is too low, contrast is too high, and contrast is too low. If we can make a test here, this one actually will clear lots of your doubt. Um, these things are taken from one of the book, uh, I think DSP book, and the brightness and contrast testing. This you can write a small piece of program and test how actually it, how your eyes are actually, how you can very well test your eyes, how good your eyes are. Yeah, take a rectangular area where you can have three square boxes, and inside these three square boxes take two triangular shapes in each of these three square boxes. So fill this rectangular area with random values ranging from 0 to 255. Fill this first square with intensity value 75. Here, fill it with 150, fill it with 225. Now, the next part is these two triangles. Now, look at the triangle, upper triangle. Upper triangle has been filled with value 71, and the lower triangle is 79. And the numbers are very meticulously chosen, like 71 is little less than 75, and 79 is little more than 75. Similarly, the other two triangles, 146 and 154, then you have 221 and 229. All these values lie around 75, 150, and 225. And given these values, let us draw the picture. And I believe most of you would be able to recognize the triangles, all the six triangles. Is it, if it is visible, then it is okay, good. If it is not visible, then I suggest you consult some eye specialist. That would be required. Yeah. Uh, if I show you on the left hand side, the response curve that is there, input versus output, we do not change anything. Whatever is the input, the same is the output has been displayed here. Now let us do some experiments. Let us decrease the brightness. Let us decrease the brightness. Okay. Let us decrease the brightness. Um, so what has been done here is any value ranging from 0 to 100 have been forcibly made 0, and values ranging from 100 to 255, there is a linear function again. So 100 appears 0, 150 would be appearing as 50, 200 would be appearing like 100, and 250 would be appearing like 150 and so forth. So with this, you can see that the values less than 100, 0 to 100, have been forcibly made 0. So that means the first square, which was housing two triangles, the values were 75, 71, and 79. All have been made 0. That's right. So all have been made 0. Now, as far as the input is concerned, you are supplying the input, but at the output side, the response curve, it the curve is like this, and it produces 0 or the black output for the first square, and the next two squares also the brightness value have been decreased. What was 150 now it has become only 50. What was earlier 200 now it has become only 100. So the brightness have been decreased. So you are not able to visualize the first two triangles, but also you might be finding difficulty in visualizing the next four triangles, isn't it? Similarly, let us increase the brightness. So whatever the value is at 0, that is now 100. And 50 is represented with 150, 150 is represented with 250, and like that. And be above 150, whatever is there, everything has become 255. Everything has become 255. Now look at here. So those two triangles with the square, the third one, 150, sorry, 225, 221, and 229. Those values have been made forcibly 255. And moreover, the first two triangles and second two triangles are also not able to visualize. We are not able to visualize that. So this is one of the example of decreased brightness. Second example of increased brightness. Now look at this. The contrast is too high. The contrast has been made deliberately high here, around the value 75. So the values little less than 450, that might be around 45 to 105. So or 40 to 110 kind of values. Now, which was otherwise having a slope of 45, now it is still stiffer. It's still stiffer. So based on the response curve, the triangles are more pronounced. The first two triangles are more pronounced, whereas the next two triangles, they have been forcibly made 0. They have possibly made 255. So here the contrast is too high. Here is another example where the contrast has been made still high. The slope here, and compare the slope with this. This is much more stiffer. That is the reason why this has become more contrast. And moreover, another reason for that is it starts from 0 value to 255. Here also it starts from 0 to 255. Now we can have different segments where I can increase the contrast or decrease the contrast. So like that. So these are couple of examples. I hope this will actually clear your concept. What exactly a brightness is, what exactly a contrast is. When we say it's low contrast, when we say it is high contrast, there are some of the terms that one must understand before venturing into all this kind of short topic. Yeah. So our main topic here is the extreme low light image processing. So let us talk about what are the different night vision approaches are there. Different night vision approaches. If there is any question so far, you may please interrupt me and ask me. Otherwise, we'll continue. Yeah, no problem. Let's proceed. What are the different night vision approaches which we can broadly categorize as? One of them is the spectral range, another one is the intensity range. In the case of, yeah, if we talk about the electromagnetic spectrum, the humans, are capable of visualizing only a small portion of the spectrum, something around 400 to 700 nanometer. Some of the animals are having beyond our capability. Their visualization range is more than our visualization range. So, if we can somehow enhance this spectral range, then perhaps the non visible, invisible images we can be able to see. That is one way of sorting the problem out. The other way is whatever is available with us, whatever intensity range, whatever intensity that is available with us, if somehow we can amplify that, intensify that, then we'll be able to see. So these are the two broad ways with which we can approach the night vision problem. A typical electromagnetic spectrum. Here comes different ideas like thermal imaging. Thermal imaging, it actually detects the difference in temperature, and it actually creates a pattern uh, which is called as thermogram, and which is subsequently being displayed. And the as it actually creates a difference between the temperature, difference in temperature. So it can only create a grayscale image, and well, one can import some pseudo color into it and provide a colorful image. But those things are pseudo colors. Those things are pseudo colors. The advantages that we can have is we do not need any artificial light, and it's quite accurate. The values are, and as far as the moving target is concerned, and in difficult scenarios like fog, smoke, dust, these things are quite helpful. On the downside, it's quite expensive. There is another approach that I told you. There is a light amplification. If there is little bit amount of light, even smallest amount of light is there, that means a small number of photons are available. If somehow you can amplify those photons, then the lights can be visible, the images can be easily visible. So you require some kind of image intensifier. The electrons that you are looking for, the photons that you are looking for needs to be amplified, need to be multiplied, and more number of photons will be there, so you can visualize it. This one would be quite excellent solution, provided it's like a very high sensitive, highly sensitive to extremely low light situations. And if such a thing is realizable, then it would not be limited to grayscale. Rather, color images can also be generated in that. Yeah. Now, coming to the intensity range, different models that are there: gray transformation, histogram equalization, Retinex method, frequency domain, image fusion, dehazing, dedusting. The different algorithms are available. These are some of the algorithms which have been categorized in a tree. So the traditional approaches, whatever I told you at the beginning itself, that image enhancement is one of the most fundamental piece of work, fundamental task that is being used in image processing. So some of the fundamental algorithms are also there, like histogram equalization, gamma transformation, log transform. So these are all some of the very fundamental pieces of work. So this have been kept under the basket traditional approach. There is other approach like fusion based approach. There is another learning based approach. In fusion based approach, as the name suggests, it's a fusion one. So multimodal fusion, capture the images using multiple modes, multiple sources, and fuse them to produce a better quality image, or go for a high dynamic range images, go for uh, different types of enhancement techniques. Then there is a learning based approach where the at present time these are the techniques which are very much useful, very much in place: deep learning, adversarial networks, transformer based learning, and so forth. This particular slide actually describes what are the pros and cons. Gray transformation, so it's a computational complexity is low, but you can very easily lose the details. The contrast improvement can be done using histogram equalization quite wonderfully, but colors can be lost easily, noise can be amplified easily, and similarly the Retinex, frequency domain, image fusion, for each one of them, this particular slide narrates what are the pros and cons. The kind of work that we did, it actually requires some evaluations. So these evaluations, on one side, it's a subjective assessment, and on the side, it's an objective assessment. So in subjective assessment, our fellow researchers, fellow lab mates are being asked to observe the images and rate the images. Whatever they see, they observe it and rate in a scale. Those kind of evaluations are pretty much subjective in nature, and on the positive side, it actually helps us in understanding what the people are looking for. When you show the images to different genre of people, different class of people. So what actually they are looking for. So contextually, you will be much more richer as far as your algorithm is concerned. Then there are objective evaluations, and it's some objective standards are there. Um, it's like for any kind of quick execution, for the sake of simplicity, some quantitative calculations are being made, and you do not require a set of people here who can see and judge it. You have the mathematical formulae, subject the results to those formulae and get the results. Some of the objective evaluations here, uh, mean value is one such evaluation which actually doesn't require any reference image. So mean of the how the mean of the image is changing, the average gradient, how they are changing from the uh, degraded image to the enhanced image, entropy, how much improvement you've got. These are a couple of more uh, evaluation metrics: mean absolute error, square error, PSNR, squared standard one, structural similarity index metric, and UQI, Universal Image Quality Index. These are some of the this metric. Okay, so now let us come to the typical works that we have done in this regard. The We have used two different data sets, LOL and SICE, the 12 and 13. 12 and 13. Yeah. This is VMBC 2018 and Transaction and Image Processing 2018. These are the two work that was being used to that have been referred to get this data sets. So the first work is a multi-scale cross-connection network consisting, it comprises three sub-networks. And the first block of the model is used to extract the features, of course, in multiple scales. The second block is all about cross connection, that is used to share the features among the different image scales. And we have a calibrated convolutional neural network as the third block, that helps to predict the features. And finally, some comparisons are being done. So, multi-scale selection, here the scale in the form of the spatial scales, that is the resolution part also. One of the scale is the full image, the smaller one, like that. At different scales, the images are collected. And this is how the synthetically the low light images have also been generated. Yeah, I forgot to mention this, that in our work, two types of images have been taken. One kind of images which have been degraded synthetically. The the brightness have been decreased. deliberately. There is another set of photographs where the images have been captured under true low light conditions. So now you can see the images where we have synthetically degraded, we have a ground truth. But for the other case, we do not have a ground truth. Do not have a ground truth. So this is how synthetically degradation have been done. So we collect the, pass it through some, there is different channels are there, red, green, blue, different three channels are there. Use the red, green, blue channels to convert it into hue, saturation, and value channels. And in this hue, saturation, and value, we do not touch the hue, we do not touch the saturation. Only thing is the value is being manipulated by some percentage. And finally, we get H as V prime, which is again converted to RGB domain. And finally, we get a low brightness images. So in addition to this, some couple of image augmentation techniques have also been done. So these are the images for whom there are ground truths available. Now there are other set of images which have been captured under actual low light conditions and that do not have any ground truth. Okay, so this is one of our first network, the multi-scale cross-connection network. So the images acquired from each scale, scale 1, 2, and 3, they have been fed to this network. And with sharing of the features from each of these block to each of these left side layer to the right hand side layer with all possible cross connection and followed by a calibrated CNN. So this actually leads to some interesting piece of work like the calibrated CNN architecture. Uh, this performs with couple of convolution, max pooling, upscaling, and some pixel-wise operations. And that's what the result that we get as that's a synthetically low light image, that's a reference image. So you can very well see here the images are more or less in all the cases. It's quite good. It's quite good. Yeah. So there is another piece of work done that the first work is a very rudimentary kind of work, very preliminary. So the work we tried some pixel shuffling, some inverse shuffling, tried to use some graph convolutional network where this is what a typical max pooling operation. Now, in the case of this mechanism, some pixel shuffling and inverse shuffling happens. So, yeah, this is what the improvement over the last piece of network. Here we introduce the graph convolutional network. That is, you have this graph convolutional block that is being introduced here. The left hand side is the actual UNet that has been used. And at this bottleneck part, the graph convolutional network is being introduced here. This also produces quite decent result. Uh, but there are a couple of instances here that I must explain you that the result that we are looking here are indeed some good piece of result. Like, let me zoom it further. Yeah, uh, these are some of the box plots about the on box plots of the PSNR that have been obtained. Then we have couple of box plots here for the mean squared error. We have a box plots for MSSS IAM. Here we have again another structural similarity index and so on. So these are some of the box plots that have been there. Now, as we can see, the results that we obtain, first of all, this enlighten GAN, Uretinex, 0DCE, 0DCE these people have some outliers, and we do not have any such outliers. Moreover, the median value that have been written here with these dots, the mean value what have been presented here, look at the mean value or look at the median value. That is uh, even better than the most of the other methods, even better than the upper quartile. Similarly, if you look at in the case of mean squared error, look at here, the mean value is lower than the lower quartile of rest of the. So, and more than that, yeah, here it is quite evenly distributed, but yeah, here we have some instances. In the case of SSIM, look at this SGM, look at this Enlighten GAN, here Retinex. Here in these methods, the mean and median are quite separated, whereas in the rest of the methods, mean medians are quite close. And more than that, look at this 0 DCE, where the lower quartile is much larger than the upper one, whereas in our case, it is a uniform one. That is, these are some of the observations that can be made out of it, and that actually had impressed our reviewers, and we got it published. So these are a couple of results that are there. Yeah, the upper images, they these are no reference. There are no ground truths are there. So we have represented using entropy. First one and second one is the brisk. Entropy brisk. The first row is without any reference. Second one is a reference based one. Like this has been made. So to summarize this piece of contribution, that's actually a very considerably very fast and lightweight low light image enhancement technique, and the number of parameters are only 3.32 million, and the inference time is just 22 milliseconds. And of course, couple of advantages are there, couple of disadvantages are there. Yeah, look at the disadvantages. Here is the low light image on the left hand side without any reference. This is a true low light image. True low light image. This low light image has been enhanced with this particular algorithm. So, yeah, we can see many things here. The tree is completely invisible, whereas the tree is visible here. There are so many persons are here, the persons were not visible, here the persons are visible. So there are a lot many things are there that are visible, that were not visible here on the left hand side, but on the right hand side they are visible. But on the downside, if you see the this particular area have been overexposed. So we can say that though it is a low light image, though it is a low light image, there exist some segments of the image which are indeed overexposed. There the brightness is too high. If we talk about the segment wise, is in terms of smaller segment if we talk. But overall, if you see, yeah, it's a low light image. It's a low light image. But when we enhance this image, here we are introducing a lot many amount of noise as well as the brightness become too high. That is what the disadvantage of this particular method. So, in order to solve this, what we thought of, why not to compensate the exposure? Whatever amount of exposure have been there, let us compute that, estimate that exposure, and try to calibrate that, compensate that. And for that reason, we need to have a modification in the enhancement. And for that reason, again, we need to have a modification in the fusion. And this is what have been done here in this. We had the same unit architecture as earlier. However, we introduced an exposure calibration block that will indeed first estimate the exposure and then subsequently calibrate the exposure. So this particular block together with this block followed by the same piece of network. Now there is a small modification starting from the first one to the second one. Now this is the third one. And indeed, this gives us some pretty good results. Yeah. Now look at this. The same image which was overexposed here, it was more brightness was there. Now this has been little bit compensated, and this piece is looking much better. I hope you can visualize the difference. So that's how it is. Then yeah, this here you can see. Yeah, just give me a minute of break. Yeah. So I hope you have gone through the pictures in the meantime. Can you see the difference between B and C? Between A and B, C, there's definitely a big difference, but between B and C, can you see some difference? The difference comes with uh, in terms of this light, these bulbs. You can see how the texture that are there in the tree is much more pronounced in the case of C. So these are some of the improvements that have been done. This is again another piece of result. These are some of the results. Again, in terms of box plots that actually talks about the entire work, entire results in box plot. That's how the box plots are very wonderful. Yeah. So these are some of the works that have been done, and then at the end we thought why not to work on some thermal imagery, and the thermal dataset was also created and tried to fuse this data together and create a new set of work. I'll show you the result that will actually you will be you would appreciate the work. This is what the low light image is. Yeah, this is what the low light image is. The this one is the this red color part which has been cropped here. Then this is what a thermal image is. Yeah, you can see the same viewpoint. The thermal image, it clearly shows there is a guy here. Then there's a conversion. Now, this is what our proposal is. Some amount of colors have been also been introduced, as well as the person is also visible. So this one is in the visible spectrum. E is in visible spectrum, whereas C is the thermal image, and A is the source one, source image in visible spectrum. So this is another piece of work that was done. So that's it. If you have any questions, you are most welcome to ask. We have 15 minutes around left. You may ask, shoot any questions if you would like.
Yes, participants, any queries?
Yeah, hello.
Yes,
Am I
hello.
audible?
Yeah, you're audible,
Yeah,
sir.
yeah, loud
I
and
am
clear. Please
Dr.
say.
Uttam Kumar Kar from CCT Bhilai, sir. I am from Mechanical Engineering Department. So, sir, if I have a one casting product, I made a component by using casting method. but inside that some porosity is there. Is it possible to identify that porosity by using this image processing?
Casting product and porosity.
Yeah, in casting, during casting, some porosity is present inside that component. So, is it possible to identify by using this image processing?
I'm not sure about it, but perhaps, but I know this kind of works actually involve some non-destructive testing.
Yeah,
Is
yeah,
it? Are you
yeah.
hinting towards that?
Nowadays they are using, but by using this image processing, is it possible?
I'm not sure. I have never explored in this direction.
Okay, sir.
But this entity kind of things people are exploring, that is what I know. But as far as image is concerned, I'm not sure. I have never explored in that direction. I'm sorry.
Okay, 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 sir. Thank you, sir.
Any other query?
So is this tool is specific for some specific applications type images, or it is open to all? Suppose if it is open to medical images, if I want to take some images of the geography or something like soil, is this available for all the images, or it is specific for some specific type of application images?
Well, as far as computer vision is concerned, image processing, computer vision is concerned, they are all application specific. We cannot have a generic one. But then the same set of algorithms can definitely be tuned for application specific. That is quite possible. That is quite possible. A small amount of fine tuning would definitely would yield good result. But as such, uh, not like that. Whatever is available, just plug and play, and it starts working. No, it doesn't happen in that way. Some amount of fine tuning is definitely required. Any other question?
Any other question?
Yes,
Sandhya
Sandhya
Sahu?
Sahu.
Yes. S- Sandhya Sahu, ma'am, any doubt?
Hello, good evening, sir and ma'am. I want to understand again brightness and contrast testing, sir. Brightness and
I
contrast.
couldn't hear you, madam. Could you
Yes, ma'am.
please
Please be
be
loud.
loud little bit?
Yes, sir. Sir, I am saying I want to again understand the contrast and brightness testing.
Acha, contrast,
Contrast and
brightness and
brightness
contrast
testing.
is okay. Okay. So you are you are looking for this particular slide. You are asking.
Yes, sir.
Is
Please.
this what you are asking?
Yes, sir. Please and next slide.
Yeah. What is the difficulty here?
Sir, I am not able to understand that how sometimes something is not visible. After reducing, it is visible in some picture and some it is not visible in another. Changing the by changing the value, sometimes the things are visible and sometimes not. How, sir?
Here, is it visible here? All the six triangles.
Yes, sir.
So, is it visible all the six triangles?
Yes, sir. In first one, we are not able to see the middle portion in black one.
Yeah, but four out of six triangles are visible.
Yes, sir.
Four are visible. The right hand side four are visible. The left hand side two are not visible. Is that
Yes,
right?
yes, sir.
Yeah. The the answer is very simple. If you look at the left hand side plot, the input versus output plot, the input side is 0 to 100 have been forcibly made as 0 at the output side. So whatever is available at 50 in the input side, what is the corresponding output value? 0, isn't it?
Yes, sir.
Now let me go back to the previous slide. Here, what is the triangle values? 71 and 79? 71 and 79, isn't it?
Yes, sir.
Yeah. Now, what we have done here, anything below 100 have been made 0.
Yes, sir.
So
I
here
understand.
71 is also there, 79 is also there, 75 is also there.
Yes, sir. I
So
understand.
all values have been forcibly made 0. So that is why this output is 0. And you are not able to visualize the
Yes,
square, the triangles, all are 0. So there is no contrast between the square and the triangles. So there is no contrast. That means the background and foreground both fuse with each other. So you're not able to see that. And the other part is this slope. Now the slope, though the slope is equal to 1, slope is still is equal to 1, but it has been offset. It has an offset. Like whatever value 150 was there, now the output it is 50. 150 has been mapped to 50. 200 has been mapped to 100. 250 has been mapped to 150. So earlier what was being shown as 200, now it is being shown as 150. Sorry, earlier whatever was shown as 250, now it is being shown as 150. So obviously the brightness has been lowered. So that's the thing. On the previous slide, look at the images. These are properly lit images with ambient light, whereas here the images are little bit dark. That is how, that is what the entire thing is all about.
yes, sir. Thank you, sir.
Any other question?
Any other question?
Yeah. Yeah, if there isn't any question, thank you.
Yes, yes, sir. I think there is no query now. So thank you very much, sir, for your enlightening and inspiring session. Uh, your detailed explanation of computer vision using AI, using while giving the practical examples, has broadened the understanding of how AI-driven visual technologies are transforming the engineer and current research landscape. And on behalf of the organizing committee and all participants, I sincerely thank you, sir, for sharing your knowledge, experience, and time with us. And it has been a great privilege to have you with us and to be a part of this FDP, sir. Thank you for giving your valuable time, sir. Hoping to listen you again in coming FDPs and other events. Thank
Thank
you.
you.
Yes, sir. Thank you.
Thank you. Yes. Thank
Namaskar.
you.
Okay, participants, now at 7:30 we will meet again. We have time to start our next session. at 7:30 p.m. We will meet sharp for our next session. And our guest speaker will be Dr. Gaurav Srivastav, sir. And so please be wait for a few minutes and we will join again. We will start our session at the 7:30 p.m. sharp. Thank you. And on the meanwhile, I'm sharing the feedback link. So I've shared the feedback link here. For those whose feedback form is not working, then okay, Dr. Ravi Kumar sir, can you please mute yourself? Dr. Ravi Kumar sir. Abhishek sir, I have already shared in the WhatsApp group also. The feedback link I have shared in the WhatsApp group also. Kindly check. If it's not working, the chat box in the both videos I have shared the chat box. Sorry, the feedback link. Dr. Ravi Kumar sir. Okay, thank you. Okay, so next expert has joined with us. Welcome, Dr. Srivastava sir, Gaurav Srivastava sir.
Thank you, ma'am.
Yes, sir. So the participants, it's time to go ahead with our next session, and it's my pleasure to welcome Dr. Gaurav Srivastava sir, who is AI and data science specialist at Siemens Limited, as our today's esteemed expert speaker for our FDP program. Dr. Srivastava is a distinguished professional with over 12 years of combined academic and industry experience, specializing in artificial intelligence, machine learning, deep learning, and telecom systems. His career bridges the cutting edge AI research with real world industrial applications across the education, healthcare, and telecommunication field. At Siemens Limited, Dr. Srivastava plays a pivotal role in advancing AI driven industrial automation and predictive analytics. Sir, key contributions include developing the machine learning pipelines for equipment health monitoring, designing the intelligent feedback systems for manufacturing optimization, and implementing the generative AI based models for process automation and decision support with the Industry 4.0 ecosystem. We are truly honored, sir, to have you with us today to share your valuable insights and expertise in the emerging and transformative domain of artificial intelligence. So once again, I welcome you, sir, on behalf of organizing committee and our Sri Shankaracharya Technical Campus. Thank you for giving your time. Uh,
Thank you, ma'am, for your kind words. It means a lot. So, I would like to say good evening to everyone. I hope everyone is awake and will enjoy the session. I
it's
know.
back-to-back sessions. We have started with us.
Yeah, that's why I'm saying
Yes.
that. Yes. So, we are going to talk about the one of the thing that is means dominating these days, and that is basically NLP. Let me share my screen first.
Yes, sir. Yes.
So in that way, we will be able to talk better. I hope it's visible.
Yes, sir. It's visible. Yes.
So the agenda that we are going to discuss today is natural language processing, AI for text. So these days we are dealing with a lot of LLMs like ChatGPT. We are having Gemini, Claude. We are having Perplexity, Menistral. So there are a lot of LLMs that with those we are dealing with. And all of a sudden, we have seen there is a rapid advancements in the direction of the natural language processing, and people means started demanding about the systems those are based upon natural language processing. But why we are using it means why all of a sudden we are requiring a system which is language based, right? And what was the limitation in the existing system? There were things like pre-trained models in the computer vision. What was the requirement of the natural language processing? That I want to understand from you. What was the main issue that we were facing in the area of the language, so that we need to move ahead from the traditional machine learning models, or from, you can say, from rule based system to the more advanced transformers. Is there having anyone is having any answer for that? Why we require to move ahead, and we require such a system for the language understanding? What was the one issue that we were facing? Anyone is having any answer? Please feel free to speak. This is not a lecture. I'm not your teacher. I'm not going to deduct any marks, right? So speak freely if whatever you think that may be your opinion, but we will try to keep this session bit interactive. In that way, we will be able to learn things in a better way. So anyone is having any answer? Why we require such advanced NLP models? Anyone? Please speak up.
So,
So
yes,
earlier,
anything?
for anything to be done with the computer, we need to do programming. Actually, a computer only understood the programming language as a source code or a high level language or middle level language. But using NLP, whatever we talk in general, in any language, that language can now computer understands and it gives the answer in the same form. Earlier, it was through only programming. Every
Yes.
time we need to program to if we want anything done by computer. That is the
Hmm.
most important part of NLP. Actually, now we can give instruction in any language in any form.
Hmm.
It takes it as instruction and it does
Right.
the work.
Right. Anyone? Anyone else? Anyone else is having any other opinion apart from this? Apart from Dr. Piyush?
द फील्ड इज नॉट क्या बोल सकते हैं, अभी तक बहुत ज़्यादा एक्सप्लोर नहीं किया गया है, इसमें बहुत सारी
Hmm.
संभावनाएं हैं अभी देखने के लिए
Hmm.
और एक्यूरेसी के लिए।
Okay. So, okay, fine. So, there was NLP systems before. There were NLP systems before. Uh, like there were rule-based systems, right? Semantic web, you might have heard about it. There were systems before, but the main problem with these systems was that
That computational power was not available at that time, sir. Actually,
even
deep
then,
learning
even sir,
implementation.
let me add you, computational power was there. There were supercomputers before the transformers, right? So computational power were there. If we talk about the individual devices, we will have the NVIDIA DGX and uh, we were having the RTX and GTX systems. They were available. But why we are running towards this advanced NLP is the one thing that we were not able to capture, and that was context. Let me write it for you. Context. Right. There was no system which was able to understand the context. Right. And if there is no system which can understand the context, it cannot produce the correct result. Right. I hope this is clear to everyone. So main agenda which was hurting to the scientists, people at Google Brain, they were researching about it from apart around 17 years. Um, there were scientists like Ashish Vaswani, there were scientists like Jacob Devlin. So all these scientists were there. They were working continuously to make a model that can understand the context. If I talk about Google Translate in year 2017, 18, 2018, if you see these years, if you translate things, right, you might feel that the model or the machine that is translating, or the program which is translating the language, is more a rule based. It is a very formal way of translation, right? But what happens, like, okay, right, my name is Gaurav and I'm going home. So sometime what happens that instead of writing, if I want to translate it from English to Hindi, so sometime what happens that it may not understand the context, it may not understand the gender, it may not understand the name, it may not understand where I'm going. So the context was missing. It may translate jata hu to jati hu. It may translate that I'm it may not be able to translate things in a formal way, uh, that it should be, right? So the one thing that with that we were struggling since the beginning of the with all the developments in the natural language processing was the context. So we were requiring a system which can understand the context. So when we talk about the natural language processing, the NLP, why we are studying NLP? Because, okay, here there are two things. One is NL and another one is P. Right. Here we are not talking about the human to human communication. Here we are not talking about the human to human communication. Here we are talking about the human to machine, human to machine interaction, and machine to human interaction. Why I'm talking about this? So if you see the chat GPT, as a human we interact with the machine, and machine produces response and it interacts with the human. So the thing that is
residing here, machine to machine understanding, for machine to machine understanding, for generating the response, for understanding the language, what we require the processing of the natural language, right? So there are two things that we are doing in natural language processing. One, that is NLU, and another one is NLG. These days, what we are doing, we are doing NLU and we are doing NLG, and combinedly this is called as NLP. So what is U here? This is basically natural language understanding. We require a system that can understand the language, and after understanding the language, it can generate the response. Can generate the response. So these two things are the main uh, pilots, or the main things those were required for understanding the context. So here we are going to talk about not just the semantic meaning. If I talk about the semantic, if a few people are not from the NLP domain, for those also, I'm just going to tell you two things. One is semantic analysis of the language, and another one is pragmatic analysis of the language. Pragmatic analysis of the language. So when we say that, okay, semantic, what is semantic? When we say what is semantic, so semantic means the literal meaning. The literal meaning. Like I am living in Delhi NCR, so these days we say that okay, there are too much smoke outside. So say there, suppose I'm saying that there is smog outside. So, in literal sense, I am talking about okay, there is smog, there is pollution outside. But there comes a pragmatic analysis. Pragmatic means what exactly I'm mean. What exactly I meant from this. If I'm saying okay, there is smog outside. This brings us the context. This brings us the intent, and this brings us the motive of the speaker, right? So here, if I'm saying okay, there is smog outside, so in simple words, it is simply means that okay, there is some pollution outside. But in pragmatic sense, it may be okay. I am right now standing in a room where windows are open, and there is someone else to whom I am saying that there is smog outside. When we analyze this thing through the pragmatic analysis, where we try to understand the context, where we try to understand the intent, where we try to understand the motive of the speaker, this sentence may be saying, okay, there is a smog outside, please close the window. I hope you might have understood this, right? Here, this simply here I'm not just talking about okay, there is a smog. I'm not giving you information. Here I am talking about okay, there is a condition outside. There is a condition outside. Take some action. So when you understand the context, when you understand the intent, when you understand the motive of the speaker, then you may decide the action. Let me take a very simple example. If you might not understand this, I will take another example. Okay, we will deal on this first slide for few minutes, then we will move ahead. Suppose, suppose I said, try to understand this, huh? There is a tiger on the roof. So there is a tiger on the roof. If I say this, okay. So in literal sense, what does this mean? Okay, this means there means वहाँ एक शेर या एक चीता है. There is a simple semantic meaning. This is the basic semantic meaning. Okay, this is like an information. And when we talk about the pragmatic meaning, when we talk about the pragmatic meaning, you need to understand why I'm talking suddenly from NLP. I'm suddenly talking about the semantic and pragmatic meaning. I'm just trying to bring those people who are not from the NLP domain. Why we are doing this? So When we talk about when we talk about this particular sentence, there is a tiger on the roof. Semantic meaning, information. Pragmatic meaning, I am standing uh, under the roof and someone is saying there is a tiger on the roof. So what you have to do now, what you have to do now, that thing comes from the context. What is the context now? So what is the context now? Here is the roof. On roof there is a tiger, right? And who is standing there? I am standing there, and someone is telling me all these things. So what I can do? He is basically the person who is telling me. He is basically warning me, right? And when I can understand the warning, if I'm watching this on TV, there is no problem. There is a tiger on the roof. There is no problem. But if I'm standing below the roof, if I'm standing under the roof, then this is a warning. What does it say? Run away. I hope you understand this. So, without understanding the context, your model will not work. Without understanding the context, your model will not generate the appropriate results. Your model cannot produce the accurate result until and unless it understands the language, its various components, its various analyses. It's not NLP is not just about the putting um, words together. It's not just about putting sentences together. It's not about putting paragraphs together. But it is basically two things. One is natural language generation, one is natural language understanding, and another one is natural language generation. So, when we talk about the natural language understanding, then the model or the machine should be able to understand the uh, what do you say grammar. It should understand the various components like what is the noun, what is pronoun, what is adverb, preposition, conjunction, interjunction, everything it should understand. It's not like that ki LLMs are there and they are performing. They are not performing just like that. There is a pre-trained model. I'm writing it in front of you. There is a uh, there is a pre-trained model that is running behind the entire system. I hope it is clear, right? So what we are trying to do through the NLP, we are trying to understand the context, right? And context of the language, why it is said, who is saying, what is the boundary in which I have to give the answer, right? So all these things we are going to cover in next 1.5 hour. I hope it is clear to everyone. If it is clear, please uh, let me know. You can respond through the chat boxes. You can respond through the raise hands also. Okay. Okay. Right. So now, what we are aiming in the next 1 hour and 30 minutes, what we are aiming now, that we understand how AI processes and understand the human language. And we will do two things half of the time, or 1 hour, because in just 1 hour I don't know what are your expertise, how much you are fluent with the NLP. So what we will discuss, what we will do, that we will discuss all the technologies those are working at the back end of the natural language processing models, like the chatbots and all. So, first thing, we will do this. Then we will talk about the key building blocks for the NLP pipelines. What are the embeddings? What are the transformers? What are the language models? And modern text-based AI. What are these things? And we will explore the some industry-based applications for how NLP is acting there. So we will start with the introduction to NLP, which I have already started. Core concept of the text processing, deep learning and NLP, for the NLP, transformers and BERTs, NLP for the industry use cases, and then if there is some questions, so I will take that. So as I told you, NLP is having two parts, NL and P, and this is the natural language. Natural language is the language which is spoken by humans for their communication, for for their communication. So this is the natural language. Since uh, there are documents, those are increasing very rapidly. Docs, there are blogs, there are social media publications, uh, there are scientific papers, those are coming. So what we are why we are requiring NLP. So if we see that the volume of the data, the volume of the data is increasing very rapidly. Every day, millions of blogs are coming, some hundred or thousand news research papers are coming. There are various documents, those are getting generated in form of the reports, in form of the some analysis, key insights from the different organizations. There are social media posts like we are having Twitter, we are having Instagram, we are having Facebook, we are having Reddit, we are having Quora. So we are having n number of such websites where these things are getting published, and then who are reading these? Who means if I have to do an analysis on what is the sentiment of the people on X today. So I cannot read all the tweets. Rather, what I can do, like I can take the API of the X and give it to my model, and model will do the sentiment analysis of the people, and will tell that okay, people are feeling good or bad, or feeling neutral today, or feeling stressed today. So there are the things. If you start doing manually, things will be very very difficult, and it will be a very time taking thing. But if we have a system which can understand the language, which can process the language, and which can generate the responses for that, then that thing can be very helpful for us in understanding the sentiment of the people, the behavior of the people, the pattern of the people. So a lot of things that we can do with the natural language processing. But the only thing, again, I'm telling you, the most important thing is the context, right? Context is like a boundary, right, which say that you are not allowed to go outside that, right? If in a company there is some financial documents, those are coming, and you have to tell that what was the revenue, and you have to make a paragraph of 100 words in which you have to mention that what was the revenue in last quarter. So it should not, when you say that tell me about the revenue of the last quarter, then you are fixing the thing, then you are fixing the context that you have to, okay, you have the document since the inception of the company, but you have to tell about the what is the revenue of the last quarter, right? This is what context is. This is where you are fixing your model, that okay, you have to do research, but do research in this specific domain. So this is the most important thing that we need to understand. So this is from with this I am introducing NLP to you. Again, I'm telling you, a natural language is the language which is spoken by the humans for their communication, which is used by the human for their communication. Since the volume of the data is increasing day by day, now we are not dealing with this one type of data, rather we are started dealing with the big data. So when we are having the big data, we are having variety of the data. Once we have the variety of the data, in that we are interested in the text data, and with that text data, we are trying to perform the various operations through which my motives would be satisfied. And what could be the motives that we will talk about? Right. So what is NLP? NLP is a bridge, bridging language and AI. Right. So bridging language means, as I told you, human to machine, right? Machine language, or you say machine, and again to human. So this is bridging, and this machine is based on AI. That is why we say bridging language and AI. So NLP is bridging language and artificial intelligence. A few examples we are having chat, like chat GPT. It is written here. So we were having Bard, which has been now changed to Gemini. Gemini. We are having Clued. We are having Perplexity. XITY. Perplexity. We are having Minstrel. So there are a lot of LLMs, right? So what? Okay. What we are trying to do all these with all these, so here whatever it is written here, most of the things that is used or made up application on language models, and language model is having only one aim: to predict the next word or sentence. If your model is able to predict the next word or sentence, then you can say that is a language model. So we talk about LLM, right? Here L is large, and another one, that LM is the language model, and the aim of the language model is to produce or to provide or to predict the next word or the next sentence. This is what your language models are doing. And why we are using L? That is basically used, this is used as the training data. This is basically talking about the training data large. So large training data. So we are having a language model which is trained over large training data. So we talk about, so we combinedly say it, this is a large language model, right? So large language model which is trained over large training data, what it is doing, it is trying to predict the next word or the next sentence. So this is the thing that we are trying to do through the chat gpt. You talk about the Bard, you talk about the Gemini, you talk about the Claude, Minstrel, Perplexity, whatever you name it, right? Ultimately what we are trying to do, we are trying to predict the next word or the next word or next sentence, right? And this is not like that you will produce the next word or next sentence just like random. Here the next word and next sentence will always be in a context. I hope this is clear to everyone. So this is what we are trying to do. Now Google Translate is also working. Let me just clear this screen. Right. So, whatever you talk about the Chat GPT, you talk about Google Translate, you talk about Grammarly, you talk about Siri, or Google Now, everything, all these are working on large LM, right? Why a large LM? What they are doing? They are doing NLU and they are doing NLG, natural language understanding, and based upon that, natural language generation. So, NLP has evolved in last 8 years. Pretty much, it is evolved, right? Since the earlier it was rule based NLP. That is what called as the semantic web. The semantic web based language. The language was ontology, and the language that was used for it, that was OWL. We were using for developing the language. Then modern NLP, from rule base. Then we have the machine learning models. Then we have the deep learning models. Okay. Yes, you can ask the question. Any question? Yukti Kesharwani. Okay. So I'll continue with this. If you have any question, ma'am, you may drop in the chat box. Uh, now, from the traditional NLP, we move to the machine learning based. Then we have the deep learning based. Now we are having the LLMs. So there are things. Those were challenges in the beginning, like ambiguity, context, sarcasm, multilinguality. So all these were problems uh, for the models, for the rule based models, for the rule based models, right? So these things were rectified by extensive learning, by the extensive training of the machine learning models. So after that, these things were now up to a very great extent are being overcome, are being learned by the model. And now if you see, if you talk if you interact with the chat gpt, if you interact with the gemini or any one of the large language model, they produces result in that there is less ambiguity, there is less problem with the context awareness. They understand the sarcasm, they deal with the multilinguality. For example, if I say, if I write a simple example, there is a problem which is written here, okay, like why NLP is hard, why NLP is hard. So this is the question. NLP, if we talk about the computer vision, the things were started in 1989. We have the pre-trained models in early 90s, and we have lots of developments in the field of the computer vision. But there was less work, or we can say that there was a um, you may say that the cold in the development of the NLP based models. Why? So there was ambiguity, there was context dependency, there was language diversity. There are lots of people who use slang. There is a sarcasm that may be present in the language. So all these things were not being dealt properly by the traditional systems. So what we require something which can handle all these things. If I talk about, okay, if I write a word in front of you, and if I write bank, if I write this is a word which is written in front of you. Now tell me, what do you think, what is the meaning of this thing? What is the meaning of this word? I have written a word in front of you. What do you mean by this? Anyone? Yes, like Sandhya ma'am is saying money bank or the river bank, right? So now, yes, uh,
where we can store money.
yeah, okay. There. So one thing where we can store the money, where we can store money. Okay. So here you are talking about the financial institution, right? Similarly, we have the same meaning, bank, right? This means that the one end of the and one end of the or one corner of the river, right? This is that there is two meaning of this. So this is what we talk about the ambiguity. The As I told you, since the beginning of the NLP, everything was done for language modeling, for language. Everything was being done for the language modeling. Language modeling was aimed to predict the next word, as I told you. Now, if I if I'm talking about that I am sitting at the bank of the river Gangas, so where what I'm talking about, is this the bank or the financial institution I'm talking about, or is this is the end, or this is one corner of the yes, river, right? So these things were not able to handle by the language models which were made earlier. These models get confused in understanding. Yes, Rajeshwari ma'am, you are absolutely right. So
Models were getting confused, like in which context we are talking about, right? So ambiguity was one issue. Like, I saw her duck, right? It is, this is a sentence, it is written right now. I have talked about one um, word bank in front of you. Now I have this is a sentence written in front of you. I saw her duck. What does that this mean? What does this mean? Anyone is having any answer? I saw her duck.
Yes, we may say that she's going with some ducks. So
Okay.
we may say that I
Okay.
saw her duck.
Okay. So sir is saying that here duck is a bird, right? So someone might have pet a bird, which is duck, but this is a very famous terminology in cricket. I have written this example um, as I was watching the highlights of the Women Cricket World Cup. Right. So there, uh, क्रांति जैन जीरो में आउट नहीं होता है, रादर दिस मीन्स, हाँ जीरो में आउट हो सकता है. डक मीन्स यस यू हैव स्कोर्ड जीरो, right? One thing, no. So now duck means here someone who got out on zero in cricket, and also duck means one more thing. Let me tell you, when bowler balls a bouncer, batsman ducks, batsman sits, right? So that is also a duck, to avoid the ball directly come to your face or to hit your some body part. Player get duck, right? So here you see these this is the word which is creating the ambiguity in front of the model, right? Model is not able to understand what exactly the context is. So context dependence, like bank, it is written here, yes, posture, right? Duck is a posture. So context dependency, we are having the ambiguity. There is a language diversity. Sometime what happens, okay, I generally teach whenever some FDP like this, and I have been called. So I generally teach them with one example that, okay, when you deal with the like something, it is written is in very complex English, right? What do you say that to chat GPT? Okay, tell me in Hindi, or tell me this thing in a very common spoken Hindi, right? So what happens that, okay, chat GPT not only understand the way you are writing. Okay, someone is writing, okay, um, suppose that it is written, okay, uh, it is written table. Somebody will write TBLE, somebody will write TBL. Even then these slangs, okay, are getting understood by the language model. Also someone is saying that, okay, this thing is written in English, okay. So a few days back, Diwali has gone. Some of my friends who lives in Tamil Nadu, I have to write a message to them. So what I did, okay, I wrote a message in Hindi, and then I told ChatGPT to translate it to in Tamil. So what it does, that, okay, it translates the message. It understand it. There was a limitation of the there was a limitation of the understanding of the languages which can ChatGPT or Google Translate can do. Now we are having this kind of limitation being removed with the you can say the modern language models, right? So these things, uh, sir, please mute yourself. So these things are coming these into day by day. Okay. Next thing that I'm going to talk about, the sarcasm and idioms. So this will be the last example. Then we will move faster towards the
more things. I got only 2 hours, so I will try to um, cover up the things as much as I can. Okay. So suppose that I said that, okay, I said to someone like, okay, you have done wonders, right? I have said someone to that you have done wonders. Okay, literal meaning says that I'm praising to someone. Literal meaning says everyone is understanding this, that I am simply saying that, okay, you have done wonders, right? But there is a context that I I was telling my team that you have to create this document for next presentation to the client, and um, uh, keep the XYZ points in the report, and the team comes up and I find that, okay, and team takes 24 hours, and after that they come to me and they are showing that, okay sir, this is the report and you have to present as per your requirement. And I saw that file and immediately realized that, okay, the XYZ point which was the most important, that is not present in the that is not present in the document. So I said that you have done wonders, right? I hope you are getting that. So here, this is the sarcasm I'm talking about, and this sarcasm cannot be understood until and unless you know the context. This cannot, if I write simply you have done wonders, you may take it as the compliment, you may understand that, okay, someone is trying to praise you. But once you understand the, okay, XYZ point was told to add in the document because it was the key point for the client, now client is not getting XYZ point and sir is saying that, oh, you have done wonders, this simply means that, okay, i am I am criticizing you. This is the sarcasm that I'm using for you, right? Relevant to the matter. So NLP, now again I will sum up with everything that NLP, I'm telling you, NLP is trying to NLU, NLG. In NLU, it is trying to understand the context, right? For understanding the context, you will require LM, and you will require a LM which is trained over the large data set. The dataset which have seen such examples, then only you can say that, okay, now it's fine. I understood the context. The sir is criticizing me, I have missed these points. So this is what uh, a language model or is expected to do, right? There are the things that you need to understand with the NLP, that it's not like that, okay, the machine, you are giving instructions to the machine and machine is processing and generating some responses. Nowadays if we see that our decision, we are working on hybrid mode. Let me just clear this. We are working we are working with a hybrid mode. What hybrid mode is, now we will understand through the context. Now we give human give instruction to machine, and machine produces result, and based on these results you can make the decision. You make the decision. I hope it is clear. You might have asked that, okay, I have to make a PPT, make an outline for that. Gives you the outline for that. Okay, you have made the decision that I will keep these things in my PPT. So you have made the decision based upon the machine, right? So now what exactly happened in that? Now initially human makes decision by itself. Now human makes decision with the help of machine, or machine makes decision for the human. Like a few people are using smart watches these days, and smart watches are suddenly start showing that, okay, there is some parameters, those are means rising abnormally. So what you have to do now, that start means communicating to your doctor, right? So now
the things are changed. The decision which were earlier taking, that human to human, now these decisions are human to machine, and sometimes this is machine to human. Machine is giving instructions to human that okay, this you have to do, this you have to do. So all these things, for machines to instruct the human, the machine should understand the entire context, entire domain, entire machine should have the entire information about the human, so that it can make the correct prediction at correct time, so that the human for which the decisions are made should be correct, and the whatever the result you are giving to, or whatever predictions you are giving to the human should be relevant, right? So in that way, the natural language processing is very very important. And we are now dealing with lots of language models. It's not like that. Let me just clear this again. I'm limited with the pages now. Earlier this there was only text to text generation. Now text to audio generation is also there. Audio to text generation is there. Video to text generation is there, right? Text to video generation was there, right? Audio to audio generations are there. Now, for example, text to text generation, simple. You give the prompt and ChatGPT will respond. Text to audio response. Okay, what happens that you say that ChatGPT or some advanced language models that okay, um, create audio for or create an audio file for some, yeah, some research you are doing for some. You can say that okay, make an audio file which can contain some alarm messages for or some messages which can be used to train my model. So you chat or ChatGPT, if you say that okay, generate some MP4 files, so advanced models that can generate, right? Audio to text, you speak to ChatGPT, and whatever ChatGPT generates, that is also encoded into text, right? Video to text, you give a video to ChatGPT and ask what is happening in this videos. Give me frame by frame, generate text frame by frame. So the language model is also able to do that. Audio to audio, when you interact with the voice model of ChatGPT, is hey ChatGPT, I'm having this problem, that problem, or I want to tell me about this thing, and you are dealing with the ChatGPT's voice model, it translates, right? You not only ChatGPT, but you have the Gemini, you have the language models in Gemini, sorry, in Siri, in Google now. So immediately they starts responding through the voice only. You give the text, you might have seen these days what is happening, that there are videos, those are generated through the AI. So how they are generating, they are given scenario, they are given scenes, they are given the dialogues, and through those you might have seen that the models are generating from text, they are generating the videos. So all these are happening through the NLP. Earlier, NLP was considered as only the language understanding tool, but now if you see that language models are able to generate the text, able to generate the audio, able to generate the video, able to generate audio to audio, able to generate audio to video, able to generate video to audio. I hope it is clear to everyone. So we are uh, we are not just limited to the language. We are we are this is an open-ended system now. This is open-ended system. Open-ended. This is there is no end. And with the inclusion of the RAG and all, so there was a limitation with the chat GPT and all that okay, they can provide you information up to the date of their last training. But with the RAG, with the in that we have the different technologies like LangChain, we are having Chroma DB, FAISS, all these models are there which can at the real time itself can go to the different servers, may find the keywords which you are talking about, and generate the response in the real time that you might not feel like when the language model has done that thing, right? So these the real time processing is so fast that you will not realize the difference that okay, it is coming from a local database or it is coming from some through the NLP. What made these things happen? When we are able to handle the ambiguity, context dependency, language diversity, and all these things. These are the few things that I have written in front of you. If you are able to do that, you will be able to perform all these things. I hope this is clear to everyone. Right here, in 2 hours, I'm not going to talk about the means exact coding. I will show you the coding. Definitely, I will show you the coding. But the one important thing that I want to talk about, what is the potential of NLP? People, uh, if you talk about the healthcare sector, there are the n number of documents. There are prescription of the patient. There are the reports of the patients. If you have the if you have those documents, and you can ethically process those things, you might be able to develop a healthcare system which can target a specific problem statement, right? And all these things can be done through the natural language processing, right? So these things we are going to we are talking, or we are dealing with, right? Now we have talked about, okay, we are having a system which can do a lot of things. How it is doing things, right? How it is doing things now. So if you see, there are things that those I'm talking about. Okay, first thing that we need to understand, that we are talking in NL. And even if you are from any engineering domain or from any domain, you know that machine learning model cannot understand any NL. I hope this is clear to everyone, right? Any language model or anything cannot understand any language, right? Any natural language, right? नहीं समझ सकता. If you talk about Hindi, or you talk about English, you talk about Spanish, German, or lots of Indian regional languages, your model does not understand that, right? So what? Okay, we are talking about, okay, immediately in real time ChatGPT is generating responses for me, and I'm telling you that this is not understanding the natural language. So the answer is yes, that machine do not understand the natural language. So what we can do now? If a machine, you're talking about, okay, we are processing the natural language, so that model can understand. So here comes the term processing. Here comes the term processing, right? When we talk about the processing, then this processing makes the natural language to be understood by the machine. To be understood by the machine means there is a language in which we communicate, and there is a language in which machine communicate. And again, then comes this thing, NLG. So machine takes the natural language, it processes it, and generates the natural language again. So if you see this, the entire process here, we encode the natural language so that machine can understand, and machine produces some bytes, some binary strings, and those binary strings are again decoded so that human can understand, right? So this is what we need to understand, right? There are two things. One thing that human understand, one thing we have to bring a trade-off between these two, right? We cannot go directly like, okay, I will speak, machine understand or not, I don't mind, I don't care. But it's not like that. If you are speaking and you are trying to perform the machine learning, or you are trying to perform the natural language processing, then you have to bring a trade-off between the natural language or the human and the machine. And the trade-off is basically is in form of the encoding and decoding. You encode something which machine can understand, and with that encoding, machine will generate a response, and that we will decode, so that decoded thing can be understood by the humans. I hope it is clear to everyone. Now, the next point that is written on this page and it is highlighted here. Okay, so when we talk about the processing, the first thing that comes into the picture is called pre-processing. Right now, we have to do something in which my natural language can be understood by the machine. And in order to make my language to be understood by the machine, first thing that I will do is to pre-process that language and make that language representable, representable to the representable to the machine. And what does that mean? Means whatever language you are having, you encode that. Encode that. No matter you are dealing with NLP or any other language, if you are dealing with the data analytics also, you might have seen that if there is some categorical data, if you have some text data, you do the encoding, right? So that all data will transform into numbers. And with these numbers, machine will interact and produce another numbers as the response, and with those numbers will be again decoded and will be produced in front of the humans so that they can understand the response that is being generated by the machine. So in that, we do different things. One is called tokenization. Okay, like up now, what is tokenization? We need to understand, and this is a very simple concept, and you will be able to understand this very quickly. And I will show you one example at the end of the session. Before we end of the session, so some things we will talk about and something we will see like how it is working. So tokenization means breaking. Breaking. What do you mean by breaking? Why you are breaking? What you are breaking? Now, once you talk about the breaking, breaking of the document, breaking of the paragraphs, breaking of the sentences, breaking of the words. Now, why you are doing this? Why you are doing this? Because okay, your model can process the entire document at one time, but it processes in a pipeline way, right? And the pipeline says that everything will be broken to the most smaller understandable unit, right? And if we talk about the one understandable unit in the language, that may be characters or maybe words or maybe sentences, right? So why we are breaking it? We are breaking it so that we can fetch the words those are present in the given document. If I give you 1000-page document and say that okay, you make a summary of that, okay, what you will do, you will go line by line. You cannot just go like okay, I'll just see and produce the result. No, you have to go line by line, and once you will go line by line, you will read individual words, and to create the context you have to read each individual words. You have to find which word is important, which word is impactful, which word is less impactful, and in that way we will talk about the impacts in later this session. But first of all, we have to see what are the words, right? So in a sentence, suppose that the sentence says that okay, um, let me just clear this. Suppose the sentence says that okay, uh, I am um, talking about NLP. So this means this simply means that okay, the language model, what it will do, it will break this sentence into individual words. I will be one word, am will be another word, talking will be another word, about will be another word, and NLP will be another word. And once we have broken these sentences, this sentence into individual words, these individual words are called as the tokens. This is token 1, this is token 2, this is token 3, token 4, token. 5, right? And now what we can do? So we can write it like, okay, T1, T2, T3, T4, T5, right? And if we give it an ID, suppose that 0001, 0002, 0003, 0004, and 005, right? So if I create a vector from this and I just give you this, so what I'm basically trying to do, I'm trying to create a mapping where my words are now being represented by a number. My words are now being represented by a numbers. This is what we are aiming to. We are aiming to means um, since, as I have already told you, that machines do not understand the natural language, but they understand the numbers. So what is the way we can do that? We can break the sentences into tokens, and we can give tokens and an ID, and these are called as token IDs. Now my words are represented through the token IDs, but it's not like that. Okay, just representing the words to the tokens will start giving you the context and all. So, but this is the one way of starting your natural language, converting from the text to the numbers. This is one of the things that is very important. The next thing that comes into the picture is called stop word removals. Now, in English, there are many words. Those are not putting that much impact in the meaning, or in the development of the context. So, like I am talking about NLP. So I am talking about NLP, right? So talking about NLP is more impactful than I am, right? Here this is talking about an action that is being that is been taking place about NLP, right? So here talking and NLP gives you the entire context, or talking about NLP gives you the entire context. Basically what is happening, okay, there is a talk going on NLP. So what we can do, we can remove I and am from the sentence, because these are not putting pretty much emphasis, or pretty much importance in the generation of the meaning. So one thing is breaking the entire sentence into the smaller words, and then those words, the words are called as the tokens. Then comes another thing that is called stop word removal, means those words which are not impacting the meaning that much, so remove that. Third one comes into picture, that is called stemming and lemmatization. Let me just clear the screen. Right. Huh. So next thing that we talk about, that is called as the stemming and lemmatization. Right. So in dictionary, generally base words are present. Base words are present. Like there, you may find word run in the dictionary, but you may not find word running in the dictionary, right? So there is a process to bring the base word into the picture, so that we can understand, okay, from which language or which word these everything is getting generated. So one thing that comes into picture, that is called as stemming and lemmatization. Stemming breaks the uh, word without keeping the base. Let me just give you one example, you will be able to understand this thing better. Base word. So the word is historical. The word is historical. So if we talk about the stemming and we talk about the lemmatization, right? So stemming is a word, is a way of taking the words in which it will try to change the word into the base word, but it does not try to find out the meaning, right? Like if I try to do the stemming for the historical, the word that it will generate, that will be HISTORI. right? So it breaks the word into the base word, but the base word which it has generated, that may not be found in any corpus in any dictionary, right? But once we do the lemmatization, the base word will be historical. Oh, sorry, history. So there is a process in that. What you do? There is a process in which what you do, that you break the um, just give me 1 second. Okay, so got it. Okay. So right. So, in stemming and levitation, what happens that, okay, you try to break the bigger word into the smaller word, so that you can find the meaning of that word into the dictionary. But there comes the problem. The problem is that there are chances that the word which has been broken through the stemmer may not be found in the dictionary. So the entire process of breaking the bigger word into the smaller words become a waste. So what we do lemmatization, in which what we can do, that the words those are broken may be found in the dictionary. So this is what stem and lemmatization is. Then comes, okay, uh, we have seen that we have changed the words into the vectors, in which or uh, I have just removed it. Right. So next thing that So next thing, that is importance, giving importance to the some words, right? So in that, what we can do, that there are a process of giving importance to some words as compared to the other words in a given document. So for that, we have the different techniques, like we have the bag of words, we have TF-IDF technique, right? Which word is more important can make the context. Right. So one way was that, okay, compute the frequency of the word which comes most. But in English, generally stop words comes more, or in any languages, stop words comes appears more than the main words. So it may not do the justification justice to the language. So we have to move to somewhere else. That is another technique that is called TF-IDF and all. So we move to this technique, so that we can give the importance to some words. So for that we use this. So we have the techniques, like we have the bag of words, we have the TF-IDF, but these things are not much used. But now these things are used. These are called word embeddings. Uh, so word embeddings that we need to understand. So uh, uh, I have given you one backdrop in the very beginning, that there are two things in a language model that we try to understand. Again, I'm coming on that: semantic and pragmatic. Right? Don't think like that. I'm starting this again because I don't have an intro. Just believe me. Now we are started the exact conversation now. So this is the concept now. The in comes the uh, word embeddings. Now, whenever you use any language models, right, it just don't capture the semantic meaning. I hope those people who are new to the NLP domain, and I have discussed intentionally semantics and pragmatics in the beginning of the session. So those who are new to the session now, what I'm telling you, that not only we are when we are creating any language model, we are not just um pretty much concerned about the semantics only, but we are concerned about the pragmatics. And now this is why whenever we create the vectors for words and their meanings. Also, words and meanings with the context. So all these things we are trying to do. So it's not like that, okay, we have uh, just created the vectors of the exact meaning or the literal meanings um, into into that into your model, but we are also encoding the context. So if we are encoding the context, this gives you the better understanding, as I have already discussed the tiger on the roof and all. So this gives you the very compact and clear understanding about the language. But it is also been seen that, okay, I am saying context which is more philosophical, but here in the natural language processing we are encoding that philosophy as well. So and now how we are encoding this philosophy, that we are going to see in coming slides. So these things we were talking about, and then these are the basic ML things those were happening. Then comes the more advanced things, that is sequence understanding, RNN, LSTM, GRU, and we are going to see the Kolha block right away, right? Context awareness and long range dependencies we are going to talk about. So I'll just stop this presentation for 1 second and we'll switch to uh, just give me 1 second. So I'll open now. Now, I hope this screen is visible to everyone. Right. So the entire NLP is trying to replicate. See, this is the blog in back in 2015. Right. So now we will try to understand what is written in this. Just give me 1 second. Let me open this PPT so that I can keep the context intact. So I'm just talking about that the sequential understanding with RNN, LSTM, and GRU. So once the things started getting developed, the main agenda, if you see English language, or if you see the Hindi language, or any language that you understand, uh, there are sequences that we talk about. Sequences means what? Just like it is, if you see from here to here, this is a sequence that is written. What the sequence? Here the sequence mean that sequence understanding with RNN, LSTM, and GRU. This gives you a meaning. And what could be the next word? That is the job of the language model, right? So in machine learning, or the in deep learning for NLP, basically what we are trying to do, we are trying to understand the sequences. Sequences means the paragraphs are written as the sequence of the sentences. The paragraphs or the documents as the written as the sequence of the paragraph. Books are written as the sequence of the paragraphs in different pages. So what machine learning models are trying to do, or what NLP models are trying to do, is are trying to understand the sequences. And to understand the sequence, there is one revolution came into picture or came in early development of the natural language processing, that is called as the recurrent neural networks. So till now, what we have seen that there are different programming languages, and there are the programming languages, but those programming languages are limited with the memory. And once I talk about the memory, means this simply means that okay, I'm talking about the memory of the sequences, right? Like, okay, what happens that if I there is a game that generally plays in the team games, like okay, one people says something in ear of another people, and that message is communicated to the next people, and then communicated to the next people, and by the end of that people, you might have noticed that that message becomes something else. Anyone have in this kind of game, have you ever played? Have you ever played this kind of game? The message is said to someone, and then it is passed to. So this is one example when one sequence of information is given to you, and it is being passed through the 20 units, and at the end of the unit, the original message is gets the what do you say, distorted. So uh, if someone is having issue with not able to see this, I am sending you the blog link, right? I have pinned this message. So uh, so in that way, to understand the sequences effectively, there was one approach that came into picture, that is called as the recurrent neural network. Recurrent neural network, here if you see that this xt is the input, a is the recurrent neural network operation, and then this is the output, and the same output is being rotated here. Why we are doing this? Because we it's what happens that the input that is being given to the recurrent neural network in form of the units, and these units are looks like this. Okay, there are repetitive units. One unit takes one word. Okay, like I am talking about NLP, so there are five units will be there. So that input will go to the this unit, this recurrent neural network, and this will be processed, and one output will be created, and same output will be passed to the uh, for instance, you understand that this is h0, and this is the same thing, and same thing is kept here, and same thing is passed. Now if x1 will produce the result, it knows that what is the output at the previous layer and what is the output at the current layer, so it will combine both of these things and produces the output. Then it is passed to the next layer. Now it knows that okay, what is the output at the previous layer and what is the output at the next layer. So by the end, it generates the output which have the information of all the previous layer data. But this is theoretically correct. Practically what happens, what I talked about, information goes to one person, then it goes to another person, then it goes to another person, and ultimately at the end the main information elapses, right? The main information get distorted. Same thing happens if there are few people. There are chances that some information or some original data will be retained, but if there are n number of people, there are chances that the original data will never appear in the sequence. So this thing that this thing brings you one very important towards a very important conclusion. As the sequence length increases, the performance of the RNN units gets distorted. Is that clear to everyone? Is that clear to everyone? As information increases, RNN units are not able to capture that information that effectively as it is theoretically expected to. But so what can be done? So another thing, so this problem is called as the problem of the long term dependency. So as the dependency becomes large, what happens? The original information gets elapsed. Some obvious things, maybe predicted correctly, but if there is some conclusion or there is some inferences that has to be made out of that those units, there are the chances that those information will never appear. So what is the solution? So for that, the solution that came into the picture, that is called as the LSTM network. And LSTM, the full form of LSTM is long short term memory, right? And this is again an RNN unit, and these are trying to understand the long term dependency, right? And in this, the repeated these are similar as the repeated unit of the RNN. This is the RNN in which the input of the previous layer and the current layer are passed through a activation function, that is the tan activation function, and with that the two outputs comes into picture. Then same output is being passed to the next layer and tan operation takes place. So this is basically the RNN neural network, right? But as I told you that these are not able to handle the information properly. So there comes the LSTM. LSTM comes up with the various new inclusions, and the very unique inclusion was the memory cell. Right, and the core idea behind the LSTM is this: the CT minus one. There is the operation, right? This is basically the cross product, and then there is a summation. Then this CT, this is basically the memory, right? Memory means what exactly is the earlier information, what exactly is the original information that should be retained. The important terms of the previous layers should be retained. It should not be like that, okay, the previous the means the original informations will be not retained due to the long term dependency. But what LSTM tries to do is to create CT, right? This CT is basically the memory, and this memory brings up the important information of all the previous layers. What exactly it do, that we will discuss here, step by step we will talk about. So uh, if we see, this is the layer T minus one. This is the current layer, and this is the next layer. So we have seen that, okay, there is some information that is coming from the layer T minus one, means we have some one layer that has already done some operation. So what LSTM unit do, that it takes the information from the previous layer, and or here you can say that the information of the previous word and the information of the current word, it takes and performs a sigmoid activation function, and then it passes through this function. This output is called as FT, and passes it to this cross product, right? Then what happens? Okay, why we are doing this? We are doing this to check if there is any change from the previous layer to current layer, right? If suppose that there is a thing, there is a word says that the tiger is hidden in the bushes, but when you were writing it, you have written the tiger is hiding in the bushes. So there comes two times t, the, right? The So the previous layer is talking about the current unit is talking about the. So there is no change between the previous layer and the current layer. So there is, if there is any change from the previous layer to the next layer, then only this activation function activates and produces the output. If there is no change, this will not activate, and it will say that there is no change from the previous layer to the next layer, right? So this is what happening at at the very first. So this is basically called at the cell state. This is basically talks about if there, what is the new information that we are going to store. If there is no change from the previous state to the next state, we will not require to change anything. Then comes, okay, okay, there is a change. If you see this function and this function, both are the change. Both are the same. ht minus 1, xt minus 1. Here the output is ft. Okay, here these are the, okay, this again, this is called as it. So here it is saying that, okay, there is some change. Then it is asking, if there is change, then what is the amount of change? right? So it is talking here, this particular function is talking about, okay, if there is a, suppose the previous layer was talking about there is a tiger hiding in the bushes. So the first word was the second word was the tiger. So if the first unit was talking about the, second unit is talking about the tiger, so there is a difference in the words. And there, if there is a difference in the words, then what is the value of this difference? This is being measured here, and then pass it to the then this is added it to the previous the cell state, and then some operation happens. These some operations we will talk about, right? Okay, similarly here, as I told you, this information will go here, cross product will happen, and this information will go here and do the summation. So after doing all these things, what you will find that if there is something changed from the previous layer to the next layer, then we have the information about the previous layer important data, and what is the change in the next layer or the current layer's important data, that we will store it, right? So this is basically, ct is the cell state that will that will store all the important informations, and this thing will keep on repeating. It's not like that this will remember entire sequence, but it will require. So if we are just storing the important things about the previous information, what it gives, that it gives that, okay, there are some important things, and those important things are basically creating the context. And if your system is able to create the context, if your system is able to remember the context, your system will be able to perform well. But same problem happened with the lstm also. Same problem. Okay, it performs very well up to 60-70 sequences, but once the sequence length getting increased, your LSTM models again starts failing. So we started with RNN. We try to remember here. We try to remember the long-term dependencies, but in which we failed. Theoretically we passed, but practically we failed. So we came up with another solution in which we have the limited sequence length. We have the very good model, that is LSTM. But if the sequence length increases to a specific sequence length, suppose 60-70, uh, then it starts again failing. And if it is again failing, then what is the solution? We are trying to learn the sequences, we are trying to learn the language, but we are failing with as the sequence length increasing. We have seen the two approaches, both of the approaches got failed. So what is the solution? So the next solution that was proposed by just give me attention attention all you need. So this was the research paper. Attention is all you need. This was the research paper that was published by Google Brain. Uh, if you see the scientists, the all these from Google, right? So they come up with a very good idea in which your model can remember the sequence for a very longer time. And these came in 2017, and there is an approach, like we have one approach called RNN, then we have an approach called LSTM. Now we have another approach that is called as attention. Attention. Now, if you're listening to me, I just want to clarify you one thing, that this attention is not an English word here, right? Again, we are talking about NLP, we are talking about the understanding of the sequences. Now, what I'm saying here, this attention is not an English word here in this context, but attention is a mechanism that is being developed by Google Brain in year 2015 to 2017. This paper was originally published in 2017. Okay, so they came up with one architecture, and this architecture you might know, you might have seen, you might have noticed this kind of architecture in some of the research paper you might have gone through, or some books you might have gone through, right? This is the architecture that is called in this paper only, in this paper, attention all you need, they proposed an architecture that is called transformers. And In transformers, they uses this technique which they are using as the title, attention. So they are using a technique here that is called as attention, right? And attention is, again, as I told you, this is a mathematical mechanism. And in the beginning of the entire discussion that we have started, I have already told you that language does not understand, or machines does not understand the human language. So what we can do, we can do one thing: we can encode the language, and then we can decode the language which is generated by the machine, right? Now, if you have listened to my to the entire conversation since the beginning, now you may be able to connect the threads from where I have started, right? So if you see, and if you try to connect the threads, we started with the language, we started with the encoder and decoder, now we are actually seeing encoder and decoder here, right? Here, this, the unit that is on your left hand side, if you see this image, on your left hand side, this entire thing is called as the encoders. This is called as the encoders, and this entire thing on your right hand side, this is called as the decoder. So there are inputs. The inputs are encoded, and then these are processed by this something. I'm not talking about this right now, but in few seconds or few minutes we will be talking about it. So the input is encoded and passed to this unit, and this unit is generated some output. That output we are interested in. I hope till this point you are able to catch up with me. If you have any problem, any questions, please you can ask. See, it took me 8 years to learn the transformers and a few of the language models. I basically work with Gemini, that is based on BERT, right? So I cannot guarantee you that you will understand everything, but after end of this session, I can assure you that you will have a prior knowledge. If you go and discuss something with someone else in any technical session, or if you deliver something in your lectures of NLP, you will have some very good information about all these things. Though it is very technical, but I'm trying to keep things as simple as possible. So I hope it is clear to you, right? So there are two units, encoder unit and the decoder unit. Now, if you see, here it is written nx, and here it is nx. Basically, this is not nx, but it is saying n times. Here it is saying n times, right? So to see this thing more clearly, I will give you first. I will give you this link that you can use for your reference. This is the link, and now we will move ahead towards JLMR transform. So I will give you this link as well. If you have, if you wish to learn about the transformers beyond this session, uh, and how it works, see, this is the thing that has been proposed, and this is the thing that explains this proposed thing, right? How it works. So the illustrated transformer that we are going to talk about. Right, you can watch this video. This is Andrew Ng, you might know, then JLMR and everyone is there. So, so if you see here, if we just take everything as a black box, and input is in French, and it is saying that okay, this is some text, and this is you want to translate. Okay, so there is an input, and you want some output, and you want to perform this thing through the transformer. Okay, so you just give the input. We are using most abstract view. We are not using anything else in between. We are keep on exploring what is happening inside it one by one. But for instance, you just understand this is the input and this is the output. Now, You gave this to transformer, and transformer just has done the translation. Okay, that's fine. But how it is done? So now I'm going to open this black box. Now once I open this black box, I found that okay, I gave the input. There is an encoder that encoded this input and performs the operations, some operations on this, and then pass it to the decoder, and decoder again do some operations on this and produces the output. Now, so this black box is now opened, and two things you have found that okay, inside this black box there is two units, encoder and decoder. Okay, that's fine. And if I talk about the encoder and decoder, you might know um, that the input is equals to output. That you need to understand. Okay, so once I talk about this transformer, here this is the input and this is the output. And if I talk about this transformer looks like this, right? This transformer look like this. So you have just seen one encoder and one decoder here. Instead of that, there are multiple encoders and decoder units. Those are present inside the one transformer. So what they are basically doing, encoding it again and again and again and again to understand the context completely, and then decode it very carefully. Sir, please can you mute yourself, Ravi sir?
Okay, Ravi sir, please mute yourself.
Okay, let it be. So here you will see there is not just one encoder and decoder, but there are multiple encoders and decoder units are there. They are learning and relearning the language, and this is learning and relearning again and again. Encoder is learning, again learning, again learning. Sir, can you please mute? Ma'am, mute.
Yes, Dr. Ravi Kumar sir. Yes, sir. Sorry for the disturbance.
Ma'am, as Sarabjit Kaur Dhillon, sir or ma'am, I don't know, but ma'am is saying that okay, that share these links to the
Yeah,
WhatsApp
yeah.
group.
Yes, I'm sharing, sir. Yeah, I'm
Yes,
sharing
yes. Please
the.
copy this, and I will also add my PPT. Uh, I'll share to Ajay Kumar sir, and he will share this to
Yes,
you
sir.
all.
It will be good. Yes, sir.
And I will share some codes also because 2 hours are not enough to understand all these things at
Yeah,
once.
yeah.
Yes, so I will give some codes also so that people can do hands-on, and these are very simple codes. Let me show you, um, like tokenization. These codes are visible.
Currently not, sir.
Okay, let me just stop sharing and now is it visible?
Your Google Meet screen is sharing, sir. Means the chat
Okay,
box.
okay,
That window is not sharing. Means the chat
okay,
box
okay,
is opening. Yeah.
okay, okay. Let me just. Now is it visible?
Currently not, sir. Your screen is
Now,
not sharing.
now it is sharing.
Yeah, yeah, yeah. No, it's no, no.
So I prepared these things, but I I didn't get enough time to discuss all these codes.
Yeah.
So I will give you whatever I have discussed. I will give you the entire code to sir, right? And
Yes.
very comfortably you will be able to understand all these things. I have just taken very simple examples to deal means how to deal with all the things in the NLP. Uh, Again we will move towards the transformers. Sorry, so as I was talking about, like okay, again what these things are doing, they are trying to learn and relearn again and again and again so that they can produce the very correct result. They are trying to produce the correct result, um,
no matter in terms of the translation only, but in terms of the summarization, text summarization, you may perform question and answer, you may perform the next sentence prediction, you can perform the fill in the blanks, which is called as the masked language prediction model. So you can do a lot of things with these transformers. So right now, again, as in the beginning, the transformer was a black box. Now for us, these encoders and decoders are the black boxes. So what we can do, we can start looking at one encoder, right? And these means one encoder. This encoder is copy of this encoder. Means encoders are having same architecture, right? Decoders are having same architecture. So if we open one, so it will automatically will be same for the all the encoder and decoder. So if we open one encoder, so it contains two things. One is the self attention, and another one is the feed forward neural network. Now once we open the decoder, so in decoder it is a bit different. That's okay, self attention is there, encoder decoder attention is there, and then we have the feed forward neural network. This is the basically feed forward neural network. Now again we will move towards the how it works. Now instead of taking each and every word as the input of one unit, what different transformers are doing, it takes entire sentence or entire document as the input. You might have noticed in the chat gpt, you may upload your entire book or entire thesis, or you may upload entire document, entire kpis or everything, right? So you may upload miss bulk amount of data. It is not restricting you, right? So instead, what different it is doing, instead like of just taking one input at a time as lstm and rns were taking, it is taking a large amount of input at one time, right? So suppose one unit, so all the here, everything here has been taken as input at once. So if they are taking as the input, so they will be passed through the self attention, and one score will be calculated, that is z score will be calculated, and then feed forward neural network, since they are in the form of the matrix, cannot be passed directly to the next layer, so they need to be changed in form of the feed forward neural network, as the output of the feed forward neural network, and to be passed to the next layer. Now okay, so the output is for one word will be R1, another word will be the R2, third word will be the R3, and all, and so on. So as many words we are having, those many R1, R2, R3, R4 scores will be calculated. And now if you see what is the difference that is happening here, initially your input was X1, which was a text. Now the input that is going to the another encoder unit is now a number, is now a number, right? So now from numbers will be generated, and again numbers will be generated, and again numbers will be generated, then these will be passed to the decoder units, and from those decoder units these numbers will be decoded to the text, again to the text, again to the text, and again to the text, so that we can find the most appropriate text response for each and every individual word, right? So this is how your transformer works. First of all, it you have the input, it creates the embedding. Let me tell you, embedding it not is not just only the semantic meaning, but embedding captures the meaning. Then you have three matrices, those are created by the transformer itself. One is called query matrix, another one is called key matrix, another one is called value matrix. When from the key, query and value matrices, q1 k1 and v1, q1 q2 k2 and v2, all these are computed, and after getting computed they are multiplied, like once here if you see, x1 is multiplied with this, q1 is computed, x2 is multiplied with this, and these are the weights, wq wk wv, these are the weights. Now with these are multiplied, and these query matrix, value matrix, and key matrices are being calculated, right? So uh, So once these are calculated, the scores are computed from for Q1, uh, K1 and Q2. K2 are multiplied, and for this these are two multiplied, and after this they are divided by DK, which is basically in BERT architecture or in transformer architecture, these are divided by 8, and then softmax of these things are being taken. So again and again they try to learn and relearn, and what exactly they are doing with this, they are trying to understand the context, which word is important, which word is less important, which word is kept at which place, which word has to be kept at the last. Everything is getting calculated through these transformers, and then again it is passed through the different number of iterations, and we get the exact mapping of the words those were given as the input in different language and being translated to the another language through the passing through the encoder and decoder units. So these are this is what they have proposed in this particular thing, right? If we talk about the BERT, there are two things. BERT is a large language model architecture that is of two type. One is of base model, another one is of large model. If we talk about the base BERT, then it is having 12 encoder and decoder units, and if we talk about the large BERT, then it is having 24 encoder and decoder units. And before I finish the things, I just want to tell you one thing. Let me just this thing I want to tell you. Uh, the most important thing, that the embedding. When I say that, okay, embedding captures the meaning. Okay, embedding captures the context. And then how it is capturing the context? Suppose that okay, here we say that every word is represented. You may have heard that every word is represented through 300 dimensions or 768 dimension or 1536 dimension. What does this mean? This simply means that, okay, one word is represented with its 300 similar words, or 300 similar or most closest words, right? So once you say that, okay, let me take you here. Let me take you here. Wait a minute. Just give me 1 second. Let me find. Mm. Yes. Okay, so you may ask that, okay, we may know three or four synonyms to one thing. Okay, like, okay, if I talk about apple, um, apple fruit. So how many things you know about apple? So you may say that, okay, we may talk about the sweetness of the apple, we may talk about the size of the apple, roundness of the apple, crunchiness of the apple, redness of the apple, and you score you give all these attributes of value, right? Score. Okay, but once you say that, okay, apple may be represented in form of sweetness, apple may be represented in the form of size, apple may be represented as the roundness, apple may be represented by the crunchiness, apple may be represented by the redness. But once you say that in large language model like GPT-5 and all, each word is represented by 4096 dimension. Means each word is represented by a word of four or a vector of 4096 dimension. Means a word is represented by 4096 close words. You may say that, sir, dictionary is having 40,000 words, and if each word is represented through 4096, then by the 10 words itself, the dictionary will be exhausted, right? But it's not like that. There are few traits that can be seen through the humans, that can be known to the humans, but there are some traits those are being understood by the machines. So after few traits, you may find there is a parameter which is not able to be understood by the humans but being understood by the machine, and machine gives an score. Let me give you one example. There is a book by uh, there is a book named Age of AI, and that book is written by three very famous Nobel laureates, and one was the Secretary of United States, and one was the COE, CEO.
of Google, and they are talking about in that book that there was an bacteria which was not being killed by any of the known antibody, but what they have done that they gave the all known formulation to a machine learning model, and that machine learning model finds the antibody for that bacteria which is not able to be killed by all of the known antibiotics those were present in the real world, right? So there are the relations in the words, or there are the relations between the sentences which might not be seen or which might not be found by the humans, or which may be neglected by us, by the ignorance, by the mistake, but there are the things which can be handled, or that can be produced, that can be interpreted, or which can be seen by the machine, right? So in that way only, once you say that okay, that GPT-5 here, GPT more than GPT-4 is using a 4096 dimension, means it is using each and every word. Like if I write that I am teaching NLP, so I will be represented by 4096 dimensions, where I am teaching, am will be represented by 4096 words, teaching is represented by 4096 word, and NLP will be represented by 4096 words. So the entire thing will make the context, right? If we see a thing very deeply, then only we will be able to understand the context, and the aim of the all NLP models is to understand the context very properly. In that only your large language your traditional NLPs come into picture, your large language models come into picture, and the aim, again I'm telling you, the aim of the all the language models is to produce the next word, and in order to produce the next word you need to understand the context properly. And with that, I will now stop, and I will provide all the notes, or these handouts to the concerned authority. And with this, if you have any question, you may ask.
Okay, participants, any doubts, any queries?
I
Yes,
know
sir.
this is a bit
Let's
more
explain it in
technical
a
than
more detailed
expected.
way, sir. I don't think they have some doubt. Maybe they are more curious to learn
Yes,
more. Yes.
definitely you can.
So, any doubt from the participants or any query? Okay. 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 Yes. Yes. Okay. Thank you, sir. We are very thankful to you for taking out your so valuable time to be part of this DP, and for sharing your knowledge and experience with us. Your session is truly inspiring and informative. You explained the all concepts in a very simple, practical, and in deep, which help us understand many things. How the AI is being used in real industries to make systems smarter, faster, efficient. Your examples, your ideas you shared with us gave us a clear picture, some more of how AI is changing in the way the industries work. So you have encouraged all the participants and us to think in a new ways and to explore how we can use AI in our own teaching, learning, and the research activities. So thank you, sir, on behalf of the organizing committee and all the participants. I thank you for your time, effort, and valuable contribution. I'm sure your session has added a very great value to our program and has truly motivated all of us. And we hope to have more such enlightening sessions with you in the future, sir. I'm sure we will have
Thank you, ma'am. Thank you,
sessions
ma'am.
with you in the future.
Okay, thank you,
Thank you
ma'am.
so much for giving your time, sir.
Okay, thank you, ma'am. And I'll share all the resources with the Ajay sir.
Yes, sir. We will forward to the participants.
Thank you,
Okay.
ma'am. Thank you, all the
Thank you so much,
participants.
sir. Nice
Okay, have a
meeting
great
you.
time.
Thank you, sir.
Okay, ma'am. Thank you.
Okay, so participants, now it's end of our today's session, and hope you all learned and enjoyed the session. Next tomorrow we will meet for our next session. Say at the same time 6 p.m. for our session 7. And then expert will be Dr. Anup Nandi sir from the NIT Raulkela. And then feedback link I have shared in the chat box and will share in the WhatsApp group also. Just check. I have shared the feedback link in the WhatsApp and in the chat box. And thank you all for giving your valuable time. Thank you, everyone. We will meet again tomorrow at same time at 6 p.m. for our next session for day 4, session 7. Thank you, everyone. Yes, I have shared in the whichever I have shared in the chat WhatsApp group also. You can check there. Okay. Okay. Thank you.